Section 11.5a is about the distance formula. This is a formula that we use to find the distance between 2 points on a plane. Here you see a point A and a point B. As long as you know the x and y coordinate of A and B, you can plug them into this formula to find the distance between those 2 points. Here are some examples. So we'll start with the distance formula and we'll plug our two ordered pairs in for x and y. One thing to note is the order in which you subtract the x's doesn't matter here because you're going to square the result. So whether you want to do 1 minus negative 3 or negative 3 minus 1, it should not matter. So here I'm going to do 1 minus negative 3 and then square that. And then over here, the y's, again, it doesn't matter whether you do 2 minus 0 or 0 minus 2. I'll do 2 minus 0. 1 minus negative 3 is really 1 plus 3, so that's a 4. 4 squared is 16. 2 minus 0 is 2, and 2 squared is 4. So we end up with square root of 16 plus 4, which is a square root of 20. Now your answer should be written, or be able to be written, two different ways. First of all, you should be able to simplify that radical by pulling out any perfect squares that exist. So 2 root 5 is one way to write the distance. The other way is to plug the square root of 20 into a calculator, and you get 4.5, whatever the units are. 2 root 5 is a fine answer, especially when you just want to find a distance using algebra, but if you're actually going to use the distance in a real-world problem, 4.5 is probably a better choice. In our second example, we'll find the distance here. I'm going to take negative 5 minus 7 for my x values and square that. And then I'm going to take 1 minus 6 and square those values. Negative 5 minus 7 is negative 12, and 12 squared is 144. Notice I really don't care if it's negative 12 or positive 12 because I'm squaring. 1 minus 6 is negative 5, and 5 squared is 25. So my distance here is the square root of 169. Which, if you know about perfect squares, you know that that equals 13.